In example 4.8 says to use the graph of y equals f of x to graph the function g of x is equal to 3 times f of x. So f of x is given by the shape that we have here. So I didn't want to give you the equation, and we've seen examples of this earlier in the section. So this is another piecewise defined function, and g of x is supposed to be this shape, but I'm supposed to multiply by 3. So there's your a value right there. So I'm going to do this the same way I did example 4.7. I'm going to let a be equal to 3. And then that means that the absolute value of a would also be equal to 3. And 3 is going to be larger than 1. So that means that I would interpret this as a vertical stretch. So being larger than 1 means it's going to be a stretch in the vertical definition that we saw. So this will be a vertical stretch specifically by 3. So we're going to be taking each one of the different y values and multiplying them by 3. So I'm going to start with, let's take this point on the left at -3, +1. So that's the point -3, +1. And I'm going to take the y value and I'm going to multiply it by 3. So that y value will now be 3. So I'm going to mark a point at -3, 3. And then I'm going to look at some other points. For example, I'm going to look at this x-intercept, which is located at -2, 0. And if I multiply the y value by 3, it's still going to be 0. So I can mark that point as being a part of my new function. Then I'm going to go to -1, -1. Do the same thing with this. So -1, -1. I will need to multiply that y value by 3. So that y value is now going to become -3. Notice the x value doesn't change, just the y value, and that should be red. And then I have two more sample points that would be good to do this with. The point at 2, -2. We'll multiply that y value by -3. Now, admittedly, I've made a small error here because the window is not big enough. So we're going to have to extend this window some. -5 and -6. Because once I multiply -2 by 3, it's going to go all the way to -6. So I'm going to have a point at 2, -6. And then the point that's sitting here on the x-axis is not going to go anywhere, just like the point at -2, 0 didn't go anywhere. So the whole original function was connected with straight lines, so I should be able to connect this one with straight lines as well. And I'll do the best I can to make straight lines. And that becomes the graph of G. So something that I want you to notice, every point that was above the x-axis got stretched away from the x-axis. Any point that was below the x-axis got stretched away from the x-axis as well. Just away ended up being further below. So anything that's below gets further below, anything that's above gets further above, but every point is getting further from the x-axis, with the exception of the points that are actually sitting right on top of the x-axis themselves. So this is how a vertical stretch is to be executed.